You are tuned to Iri-e-learning, and I am your host, Teacher. In this lesson on mixtures and separation, we will be comparing mixtures. Check the description box for links to all the videos related to this unit. By the end of this lesson, we should be able to distinguish the characteristics of the different types of mixtures, solutions, suspensions, and colloids, and explain the Tyndall effect. We will start with a quick review of types of mixtures. Remember, types of mixtures include solutions, suspensions, and colloids. Now it's time to compare the three types of mixtures. In this comparison, we will distinguish specific features or characteristics for the three types of mixtures, solutions, colloids, and suspensions. And our first feature is classification. Solutions, as we see, are homogeneous, whereas colloids and suspensions are heterogeneous. For particle size, solutions have the smallest particle size ranging between 0.01 to 1 nanometer. The particles of solutions are usually atoms, molecules, or ions. Ions are atoms that have either a negative or a positive charge, but we'll talk a bit more about that when we get to atomic structure. The dispersed or aggregated particles of colloids are much larger than those of solutions and range between 1 to 1,000 nanometers, whereas suspensions have the largest particles with a size greater than 1,000 nanometers, and the particles are usually large enough to be seen with the unaided eye. Then we're looking at settling out of particles. Only the particles of suspensions settle out on standing. Therefore, the particles of solutions and colloids do not settle out. Looking at the separation of components by filtration. Only the components of suspensions can be separated by filtration, whereas the components of solutions and colloids cannot be filtered. However, the components of colloids can be separated if the mixture is centrifuged. And finally, we're looking at the scattering of light. Light passes through solutions undeflected, but scatters as it passes through colloids and sometimes suspensions. Now, for suspensions, it depends on the size and the quantity of the suspended particles. Suspensions tend to block the passage of light because it is opaque. Note that the scattering of light effect is also known as the Tyndall effect because the scientist John Tyndall did a lot of work in unraveling the facts about this phenomenon. We will observe and explain the Tyndall effect in more detail next in this lesson. Tyndall effect. We spoke briefly about the Tyndall effect, or the scattering of light, when comparing the three types of mixtures. Now we will observe the phenomenon and then explain its occurrence. A green laser light is passed through two glasses containing distilled water. You may have noticed that the path of light is not visible through the water, but the green spot of light is visible on the surface opposite to the light source. Salt is added to the water in the first glass to form a salt solution. The path of the laser light is neither visible through the solution nor distilled water. Once again, notice the green dot on the surface opposite to the light source. 2 drops of milk are added to the second glass to make a colloid. This type of colloid is called an emulsion. Look at what happens next. The light path is not visible through the solution, but it is seen as a green beam through the path of the colloid. Also notice the large band of green light on the surface opposite to the light source instead of the tiny green spot of light observed previously. What did we observe from our demonstration of the Tyndall effect? Well, first, the path of light is not visible through distilled water. So how do we know then that the light was passing through? Well, this is a green laser pointer, and we noticed there was no evidence of a green light passing through the solutions, but we saw the evidence of the green spot on the surface on the opposite side of our light source. So we know the light is actually passing through. Secondly, we had a solution and distilled water, and yet again, the light passed through, but we could not see the light passing through the solution nor the distilled water. But we know it has passed through because of the evidence of that green spot on the surface opposite to the light source. And thirdly, we saw that the light path is still not visible through the solution. However, It is seen as or perceived as a green beam passing through the colloid. During the analysis and interpretation, we will explain why the path of light was visible through the colloid and not the solution. In the colloid, the particles of the milk remain dispersed throughout the water, and the dispersed particles of the colloid are larger than those of the solution. Consequently, the colloidal particles reflect or scatter the light in all directions, and this is what we call the Tyndall effect. Now, the colloid particles that scatter the light will glow, forming that green beam of light, or what we perceive as a green beam of light. Note that we are seeing green in this particular case because the light source is green in color. So whatever color light you would use, or pointer, that laser pointer you would use, you notice the beam having that particular color. Now we know that the light is scattered because of the broad green spot now observed on the surface opposite to the light source instead of the small green spot. On the other hand, light passing through the solution is not visible because the particles of the solution are too small to scatter the light significantly. So in conclusion, we can say that the Tyndall effect is the scattering of light by colloidal particles, which makes a beam of light visible. The lesson summary points include: solutions are homogeneous, while colloids and suspensions are heterogeneous. Suspensions have large insoluble particles that are visible with the unaided eye. The components of a solution and colloid do not separate on standing, nor can they be filtered. The components of a suspension settle out on standing and separate by filtration. Colloids scatter light, which is the Tyndall effect. So it's quiz time, and you have 5 seconds to answer each question after it is read aloud. Question 1. Which mixture could have particles with the size of 700 nanometers? A. Bronze, B. Whipped cream, C. Seawater, and D. Syrup and water. The answer there is B, whipped cream. For a mixture to have a particle size of 700 nanometers would mean that the particles fall in the range of 1 to 1000 nanometers, which is applicable to colloids. So the only colloid listed is whipped cream. Question 2. Michaela made a mixture that displayed the Tyndall effect. Which statement correctly explains the Tyndall effect? A. The Tyndall effect occurs when the particles of a solution scatter light to make a visible beam. B. The Tyndall effect occurs when the particles of a colloid scatter light to make a visible beam. C. The Tyndall effect occurs when the particles of a solution and colloid scatter light to make a visible beam. D. None of the above. The answer there is B. The Tyndall effect occurs when the particles of a colloid scatter light to make a visible beam. Question 3. Christopher made a heterogeneous mixture that displays the Tyndall effect. During the experiment, he noticed the insoluble particles slowly settle to the bottom of the mixture. What type of mixture did Christopher make? A. Solution, B. Colloid, C. Suspension, D. All of the above. The answer there is C, suspension. Remember, some suspensions may exhibit the Tyndall effect if there aren't many particles suspended in the liquid to make the mixture opaque. Also, since the insoluble particles settled out, this would eliminate solution or colloid as a possible answer because their particles never settle out. Question 4. Daniel mixed a spoon of insoluble starch powder into warm water. The mixture appears homogeneous and the insoluble starch particles did not filter out. She shone a red laser light through the mixture and the red beam of light was observed. What type of mixture is this? A. Suspension, B. Colloid, C. Solution, D. Solutes. And the answer is B, colloid. We know the mixture is a colloid because 1. The insoluble starch particles could not be filtered, and 2. The mixture displayed the Tyndall effect as observed by the red beam. Remember, some colloids may appear homogeneous to the unaided eye since the heterogeneous nature is observable at the microscopic level. Question 5. Identify the characteristics that are true about milk. 1. Milk is an emulsion. 2. Milk is an example of a foam foam 3, particle size is about 1 to 1000 nanometers, and 4 components can be separated by centrifugation. And our options are A, 2 only, B, 1, 2, and 3, C, 2, 3, and 4, and D, 1, 3, and 4. The answer is D, 1, 3, and 4. So remember, milk is an emulsion, which is a type of colloid. Therefore, the particle size of colloids would range between 1 to 1000 nanometers, and the components can be separated by centrifugation. We have reached the end of our lesson. If you found this video helpful, remember to like, share, and subscribe. When you subscribe, you will receive notifications as new videos are uploaded. So until next time, I am Teacher with Iri-e-learning.